Hello everyone, my name is Miriam Demirci and I'm here with an organic chemistry question, which is included almost 8 or 9 chapter of Organic Chemistry 1. So the question is name or draw out A, B, C, and D compounds in an arguably manner and in proper line angle skeletal structure. Also predict their reaction SN2, SN1, E2, E1, substitution or elimination, and the major product. So first we can see in compound A, we already have the name written. We only need to draw it here. And component B, also we have the name written, so we only need to draw it here. Component C and D, we have the compound, it's already drawn. We need to name them. So first I'm gonna start with number A, which I have to start drawing it. So we're gonna start from right to left from butane. So but is prefix for 4. It means we have 4 carbon here. So I'm gonna go ahead and draw 4 carbon. It's gonna be 1, 2, 3, and 4. So I'm gonna start 1, 2, 3, and 4. We have 4 carbon. So the next one is 3-dimethyl. So it means if I'm gonna start from here, if I put 1 here, the 3 is gonna be here. I'm gonna have two metal here. But if I'm gonna start from here, I'm gonna have 2 metal here, and di stand for 2. So okay, so I'm gonna start from here. So this is my number 1, this is 2, this is 3, and this is 4. Okay, so I'm gonna draw 2 metal here. Okay, very good. Okay, and after that, in carbon 2, we have chloro, which is right here. So we have chloro. This is my Cl, chloro. But we're not done yet because we have 2R. It means there is a chiral center here. So the chiral center means when we have 4 atom or 4 different group or 4 different atom around one atom. So which we have chloro, we have this group, and we have metal here. So, and we have a little hydrogen here. So we have 4 different group or atom around this carbon chain. So here, because it's R, if we look at it, it should be this way. So which is true, this group is bigger than this group. So this is how chloro should be, because it's true. This is the priority. So number 2, and this is our reactant. So now we need to draw out number B. So number B is ethanol. So wow, ethanol, it means we have alcohol here, we have OH, okay? I'm gonna draw out OH. So there is OH here. I'm sorry, it's just not very good. Okay, we have OH. So we have ethane, so which is ethane, it stands for 2. So we have OH, OL, and we have ethane. ET stands for 2. So this is ethanol, and we have 2 carbon, 1, 2, and here is OL, which is our alcohol. So component C, which is this one, we have to write down the name. So for write down a name, you have to follow 3 steps. So the first one, you're gonna find the long carbon chain. The step 2 is number the carbon chains. So we have the most substituent and lowest number at each substituent. And step 3 is identify the type of substituent. So first, we're gonna find the longest carbon chain. So I can start from here, start from here, or start from here. It really doesn't matter which way you go to. So I'm gonna start from here. I like to put my number 1 here, 2 here, and 3, and 4. Okay, we have 1, 2, 3, 4, which is 4. Okay, so the prefix for 4, which we said before, is but. And here, so we can start writing down but. So, but as you can see, we have here, we have this group. What is this group? So we have an ether group, which is, we have to name it different because we have ether. Okay, so I'm gonna type this down, which is a little bit hard to just write it down. Okay. Okay, so very good. So first we're gonna start with 4, which we had 4 group. It's gonna be but. And since it is an alkene, it's gonna be butane. But we just started, so we are not done. So after the first step, we have to look at the substituent. So, and I forgot to say the reason that I start from this way, there is a reason also actually, because we have an ether group and ether has priority than metal. So that's why we started from this way, and we want to have the ether, we want to go to ether sooner than metal because it has the priority. So we have butane, which was 4 carbon chain, and then we have to look at the substituent. So always, don't forget, always write the substituent in alphabetic order. First is gonna be here. I want to write down because this is a toxic group and this is dimetal, which we had it here, and it's like the same thing. And because we have 2 atoll, so we call it dietol. So the first thing is gonna be, which is in the number 2, is gonna be 2 toxy So we're done with this part, but we have to do this one too, which is going to be 2 otoxy and 3, which is 2 di metal and dash. But we're not done actually, because we don't have a chiral center here. As you can see, there's no chiral center here, and the reason is we do have two different group here, which is this side and this side, but we don't have a different group here. We have two metal, which is the same thing. So there is no four different group or four different atom here. But here, yes, we do have four different group and atom. So which is this group, and this group, and this group. So what we have to call it, so this group has priority than this group, so it's gonna be clockwise, is gonna be that way, which is gonna be again R. So R is clockwise and S is opposite this way. So which is in substituent 2, which is in the position 2, is going to be 2R, same as component A. And we always put them in parentheses, 2R. Don't forget the dash. Okay, so we are done with part C. So we're gonna start with part D. Which is here. So as soon as I look at part D, I can see we have a double bond. So it means it's gonna be alkane. So it's gonna be alkane, it's not alkene anymore. So it's gonna end by ene, by E and E. So the first step is to name the longest carbon chain. So we can do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. But we have to look at the priority, which one it has a priority, and then the rest of them, which is this side. So we're gonna start with this side, which I'm gonna have to draw it. So this is 1, this is 2, this is 3, and this is 4. Okay. So 1, 2, 3, 4. We have 4, same as the other one. It's gonna be again. It's gonna be again same thing. So but but we don't have the alkene anymore. We have alkane, which is En, and with ENE. So here it's gonna be butane. So we have to look at the second step is look at the different substituents, which we have 2 here, and they are metals. So we have a metal in position 2 and one in position 3. So it's gonna be dash, which is 2, 3, dash, di, metal. So as I said before, since we have 2 metals, the prefix is dimetal because we have 2 here. And when we have 2 same substituent, we separate them with a comma, like here, should be comma, not a dash. So always just remember there is no space and nothing should to be capitalized, and always it should to be alphabetic order. So we're gonna go for the second step, which is the predict the reaction, SN2, SN1, E2, E1, substitution or elimination, and the major product. So here, as we can see, so by just looking at it, we have two different products, right? Okay, so then there is no, let me draw, lose my pen. So there is no SN2 or even E2. So we're gonna end up just have SN1 and E1, which is gonna be substituent eliminations. Okay, which one is SN1 and which one is E1? By only just looking at them, I can tell you this one is E1 or elimination. Why? Because we have double bond. It's easy, right? Okay, and this one is SN1. So this one's gonna be our substitution reaction, and this is elimination reaction. So, but we have to predict which one is, and I said this one is, let's write it down. This one is S, I'm sorry, handwriting is not really good. This is SN1, this is E1. Okay, very good. So now we have to predict which one is a major product for, between those two. So we have two products for SN1 and two products for E1. But how can we figure out which one is a major product? So for SN1, we can figure out the major product by looking at the nuclei, which are here. So this is our nuclei, this is the leaving group. So leaving group leave and nuclei just go here. So when you have an SN1 or E1 reaction, it is possible to have more than one product. So for SN1, the priority is it's due to carbocation intermediate stability. So which we look at which one it's tertiary, secondary, or primary. Here our nucleophile site, it's in here, which it was secondary. It's not bad, but it's not good also. But here, which you can see, it's tertiary. So of course I like tertiary better. So this is our major product due to carbocation intermediate stability. So this is the major product. That's the major product. And for elimination or E1, how can we figure out which one is a major product? So it is due to Zaitsev rule. So E1, when you have an E1 reaction, you have a choice of where a double bond is going to form. So Zaitsev's rule is that the alkene formed in greatest amount is the one that corresponds to removal of the hydrogen from the beta carbon, having the few hydrogen substituent, which it's a little bit hard, but it's easy to say. So double bond wants to go to an area that there is not a lot of hydrogen around. So as you look at here, we have double bond here. There's no hydrogen here because it's already 4 groups. So this is SN2, but here is attached to 2 hydrogen, right? But here, as you can see, there is no hydrogen, which is like to be here because it's going to be more stable, it's going to be low in energy, which I'd like it to be here. So this is going to be the major product. So this is the major product. So this is the major product, and we're done with this question. I hope you guys could understand this well, and thank you for listening to me.